Hi students, so already in the motion lesson part 1, part 2 you have learned. Now the part 3. In the part 2 and part 1 you have learned about speed, velocity, uniform motion, non-uniform motion. Now you are going to learn acceleration. It is very easy to understand what is acceleration. Okay, so here acceleration means suppose you are going on a bicycle, you are increasing its speed by applying a force. That means you are changing your speed. So that change in the speed with respect to time, someone can change the speed very quickly and someone very slowly they can change the speed. So that change in the speed with respect to time is acceleration. That means change in the velocity over a period of time is acceleration. That means the rate of change of velocity is acceleration. So what is acceleration? The rate of change of velocity. Understood? So acceleration is rate of change of velocity. So if you take all these quantities, the fundamental quantities, derived quantities, vectors, scalars, depending upon the direction and magnitude, we can say a scalar is having only magnitude and a vector is having both magnitude and direction. Then you must got it out, acceleration is a vector or a scalar. Acceleration is a vector. That means it is having both magnitude and as well as direction. So it includes the direction also. Okay, suppose for example a body is traveling with a constant speed, but there is a change in the direction, okay, or change in the direction of acceleration is changing, okay, then we say the body is under acceleration even though speed does not changes. Even the speed does not changes, direction of acceleration changes, then we say the body is under acceleration. Okay, that means when you want to increase the speed, what you will do, you will apply the accelerator, whether it is automobiles, okay, then you will apply the accelerator, then the acceleration is in the positive direction. When you want to stop suddenly, you will apply the brakes, then the acceleration is in the negative direction. So acceleration can be positive and can be negative. So negative acceleration is called deceleration. Okay, that means velocity can be increased or velocity can be decreased. That means the direction of object changes. Okay, that means acceleration also changes its direction. The object of direction changes means object direction, whether it is going in the one forward direction or backward direction, whether it is applying the brakes, object will move in the forward direction, but the direction of the acceleration in the opposite direction. So velocity will be negative. So when the velocity is negative, acceleration is also negative. So acceleration can be positive or negative. So negative acceleration is called what? Deceleration. So what is the direction of acceleration? It is always along the direction of change of velocity. Velocity in which the direction is changing. Velocity is changing in which direction? Whether it is in the positive velocity or negative velocity or positive acceleration and negative acceleration you can define. Okay. By what? By direction of change of velocity. Then how can you calculate the acceleration? What is the letter of indicating the acceleration? Acceleration is indicated with the letter small a, not capital A, small a. What is the formula? Change in velocity by changing time or rate of change of velocity. Delta is a symbol which indicates the change. Okay, change delta v, change in velocity, delta t, change in time. Okay, so change in the velocity, initial velocity is indicated with a letter u, and final velocity is indicated with a letter v. Then final velocity minus initial velocity, that means v minus u by t is a formula for a. Okay, then in terms of units, what are the units of acceleration in SI units? That is velocity, it is meter per second by second, meter per second by second, it is meter per second square. So what are the units for acceleration? Meter per second square. So what is the formula for acceleration? Delta v by delta t, or v minus u by t. Can it be positive or negative? It can be both positive and also negative, and also zero acceleration also you will learn in the next. So acceleration formula is v minus u by t. Let us do a small calculation. So calculating the acceleration. For suppose a penguin is on the icebergs. Okay, it is at a rest initially, and it came down, slides down, and reaching a speed after some time. Okay, let us do one question. So a resting penguin, that means initially the penguin is at rest. At rest means initial velocity is always equal to 0. Good. So it slides down in the icy slope. That means it is increasing its speed. So final velocity it reaches in 15 seconds is 30 meter per second. So final velocity v is equal to 30, u is equal to 0, and time, in what time it reached 30? 15 seconds. That means acceleration is v minus u by t. That means I will give you just 20 seconds time to calculate. Calculate acceleration. Have you got the answer? Yes. Let us see with the answer. So initial velocity is 0 meter per second, final velocity 30, a is equal to v minus u by t, and acceleration is equal to 2 meter per second square. Have you got the answer? Very good, children. You are learned acceleration. Okay, very well. Very good. Okay, if you are not getting the answer, practice well. Another one. Another example or another sum. Okay, if an arrow moving with a velocity 80 meter per second hits the target in how many seconds? 5 seconds. So it is initially it is moving with a greater speed, comes to rest. That means initial velocity is 80, final velocity is 0 in how many seconds? 5 seconds. So do this sum in the worksheets. A skateboarder increases her velocity from 16 meter per second to 32 meter per second. In what time? 10 seconds. Okay, now what is her acceleration? This is also very easy. Acceleration formula v minus u by t. So you do it in the worksheets. Now this velocity time graph. Okay, already you have learned about the distance time graph, okay, in the previous classes. Now the velocity time graph. Time, as the time is independent quantity, this one on the x-axis, time on the x-axis, and velocity is variable quantity on the y-axis. If you note down the values on a graph, so here for 10 seconds the velocity is 10, for 20 seconds the velocity is 20. So here you will get a constant acceleration. Okay, so here a line passing through the origin with a straight line passing through the origin, it indicates a constant acceleration. In the case 2, suppose the velocity is constant. Velocity is constant. That means here for 20 seconds the speedometer reading shows 20, and for 30 seconds also the speedometer reading shows 20, and 40 seconds also the speedometer reading shows 20. Okay, then speed is not changing. Even though time is changed, speed is not changing. That means acceleration is v minus u by t, that is 0, isn't it? V minus u, that means 20 minus 20 is 0. So acceleration is 0. A straight line parallel to time axis in a velocity time graph is acceleration is 0. A line parallel to time axis. Now a car going with a speed 20 applies a brakes and the speed decreased to 10. That means velocity in the opposite direction, but car is moving in the forward direction. So negative acceleration is called deceleration. Okay. In another case, then again the car increases its speed continuously for the next 40 seconds. That means a curve indicating that there is an increase in the acceleration. Okay. Here constant acceleration, zero acceleration, negative acceleration, increase in the acceleration. Observe these graphs very carefully. Observe these graphs very carefully so that you should have a clear idea about this graph. Which graph it is? Velocity time graph. Here the one which is parallel to a straight line parallel to time axis, that means acceleration is 0. Good. A one in a downward direction, a line drawn in downward direction is deceleration. Good. A line from passing through the horizon, that means it is going with a constant acceleration. Okay children, very good. We have learned acceleration. So now finally, what is acceleration? Acceleration is, yes, rate of change of velocity. Have understood children? The part 3 was successfully completed, and the derivations and lab activity, okay, you will learn in the next part. Understood children? So be practice your sums, okay, in the worksheets. Okay, have a nice day. Bye.